Spacetime decreases when we view space looking up. We are looking into the past. The stars are so far away a trip to Alpha Centauri would take 4.3 light years. But what if told you there is a way to get to the Alpha Centauri galaxy in less than 30 days, 1 month? Well, here we go. Space, like I said, looking up, we are looking into the past. We are at the stars light years earlier because of the universe cosmological timepiece. The idea most galaxies are so far away, it will take years, light years to get there. Well, I got a surprise for you. We have the capacity for our ship to advance light speed in its propulsion engineering. Yeah, we need a good engine, a big one. So, we start on our journey. Now, according to relativity, time stops in our ship traveling that fast. Now, Alpha Centauri is 4.3 light years away. That's far, but it only takes light 1 second to travel light speed or warp 1. So, we start on our journey. Earth clocks read 1 o'clock. On Alpha Centauri, their clocks read 1 o'clock also. So 1 second passes on Earth, 1 second passes on Alpha Centauri. We are talking about seconds in travel, not hours, but that doesn't matter. We start out our trip. We reach light speed. According to relativity, time stops. But not on Earth or not on Alpha Centauri. It's all been coordinated and caliber, so we know the time on Alpha Centauri and Earth, no mistake. Now, like I said, we travel backwards through space through time. As we accelerate, we decrease and signify Earth time by acceleration at light speed. Meaning as we continue our journey, time on Earth relative to our ship traveling forwards in time. When we look backwards at Earth, it seems as though it has stopped. Time on our ship gas stopped. On Alpha Centauri, because we are traveling forwards in time on a backwards time platform, time slowly sconicizes, and when we reach Alpha Centauri spacetime coordinates, it takes less time to Alpha Centauri than the miles in light years it was away. Being time passes by the second of time on our ship, and Earth and the Alpha Centaurian galaxy time passes by the same second of time. Relativity's problem in its theory is we travel backwards in time at light speed. That's true, but traveling through the space field between Earth and Alpha Centauri, we travel backwards in time. In the ship, time equals 1 second per second. On Earth, the same. On Alpha Centauri, the same. But through space, counting light seconds, time ceases to exist. We are on a course to a far-off galaxy, traveling through space-time, whereas we travel time as we know it. On Alpha Centauri stays the same as Earth, time stays the same. But we, in our ship, travel through space, backwards as we know it, because like looking into space, we are looking into the past. How it was. Time times the distance. I hope you understand this analogy. It doesn't violate relativity. On its own, it's a new specialty physics. If we are looking into the past when look at the stars, Alpha Centauri is only a couple months away. Traveling backwards on the space speedways, time decreases. Time decreases as we begin our journey. But is it time that decreases or space that contracts? The planets are big. Earth is big. Our solar system and the galaxies even bigger yet. A ship traveling through space becomes unaware of how big these celestials are. We don't even know how deep the space field actually is. So, we look up out into the darkness at the stars. We're looking backwards in time ... but imagine a ship, a tiny ship in comparison to the planets and stars. We're like a piece of dust, if even that in the comparison. When we travel backwards through this dark field of space, we don't even notice the planets we pass by midstream the space field. We accelerate to light speed. A zero margin when it comes to clocks and time. We can go faster, we know this due to expanse, and the energy expanse pushes galaxies apart from each other. But space, that's something different. It pushes on the dark fabric around them, creating lumps like in the density field. As for the weight of the ship in vacuum, matter mimics space at 0 point energy. The same way planets only retain weight being in constant motion. They are warping the space field, but they are causing gigantic rippling. The celestials settle in the dark blindness. At least that's what it looks like. But we know the planets and celestials types orbit and rotate. They're always moving in position. A position that actually doesn't change. So they pass in circles or orbits, pressurizing the fabric around them. Meanwhile, the crew in the ship travels in a motionful pseudo-timeline that measures zero. But space contracts as the ship travels. Its velocity pushes against the space fabric but intermediate three-dimensional space around it, like a bubble. But at superluminal speeds, space opens up two layers or levels of the space. These levels measure into the subatomic realm where time acts instantaneous to momentum or changes. As the ship travels, accelerating the ship slit streams at the lowest subatomic level embedded in the fabric. The faster we accelerate in our ship faster than light speed, the more time between Alpha Centauri and Earth decreases. WHY. The space field is our time machine. Space mimics acceleration and time mimics the distance between Earth and our destination. All we have to do is accelerate to a specialty velocity and space takes over. Zero mass vacuum, zero mass environment body mass. Mimic seems to be the biggest in space travel. Propulsion, its destination towards it. Time equals distance. The quantum physics framework tries to bring forth original and new ideas about space and space travel. For instance, superluminal abilities, how-tos and what-tos.